skip the first questions. Descending order? No. Greatest common factor? No, but there is a negative leading coefficient. I have to pull it out. I have to factor out -1 first. Now I have to be careful and see what is left in parentheses. And after that, I continue with the special product. It's a binomial. So can anyone tell us, please? When we pull out -1, what is left in parentheses? -1 times something equals -x cubed. -1 times something else equals +1/27. So what do we have in parentheses? So that when we multiply them, we get this. Anyone, please? What do you think? Anybody?
Would that be x to the power of 3 minus...
Excellent. Thank you very much. X to the third minus 1/27. This times this is this. This times this is this. Excellent. So now it's a binomial, of course, and we have to make a decision. It's a difference, so I can only look at the difference of squares or difference of cubes. Is there something I square to get x cubed or something I cube to get x cubed? I know it's a silly question. So again, is it, I'm sorry?
Where?
But there is nothing I can square to get x cubed. I can cube to get x cubed. There is nothing that I can square to get x cubed. There isn't, it doesn't exist. But there is x. If I cube x, I get x cubed. So it's a difference of cubes, which means I have to prepare a binomial and then put the pattern in for the trinomial. Always, always start with a sequence of signs. If there is minus here, the binomial has minus, the trinomial has plus. In this case, you will never make a mistake if you do this. So whatever we are given is transferred to the binomial. Either minus minus plus or plus plus minus. Again here, plus plus minus, minus minus plus. Good. So now we have to identify what we cube to get this and what we cube to get this. And this is easy. Anyone, please, would like to help? It's okay if you're wrong, so please, at least I know you're here and I just not only see your names on the screen. Please. Can anyone give it a shot, please? Oliver, what do you think?
I'm actually unsure.
What do you think we cube to get x cubed? I already did it here. It's on the side.
X.
Of course. Good. Now the question is, what do we cube to get 1 over 27? So what do I cube to get 1 over 27? Anyone would like to give us a number that we raise to the third power and we get 1 over 27?
One over 9.
1 over 3, because we have to raise it to the third power. 1 to the third is 1, 3 to the third is 27. Once we identify the x and 1/3, the rest is very easy. We square x, we square 1 over 3, we multiply them, we put the middle term, and that's it. So the trinomial is always easy. The difficult part, if you want, is to identify which special product we need and to identify the binomial. Once I have the binomial, this is a piece of cake. Square, square, product. But this has to be identified correctly. X to the third is x cubed, and 1/3 to the third is 1 over 27. You can always stop and multiply. Distribute x to these three terms, negative 1/3 to these three terms, and you will see you will recover this for sure. Which means this binomial factors correctly into these three factors. One factor, the second factor, the third factor, negative 1. Good. Let's see if there is anything else here on the handout. Yes, the last one is x squared plus 16. Good. So, from the very beginning, do not skip anything. Descending order, yes. Greatest common factor, no. Negative leading coefficient, no. It's a binomial. So now I look at the special products. There are two special products with binomials, with a sum. This one, sum of squares, which is not factorable, and this one, which is sum of cubes, which is factorable. So now we have to identify. So we reach the stage in which we must identify which special product, and again, we always hope for a special product. They're much easier than the rest. So, is there a special product that we can apply here? Anyone, please?
Sum of squares?
Yes, it is a sum of squares, which is not factorable. Indeed, it's the sum of squares. There's nothing that I can cube to get x squared. There's nothing that I can cube to get 16. So this is indeed the sum of squares. It's not factorable. You can write not factorable or prime. The correct answer is not factorable using integers. Maybe prime is a better answer. But not factorable, we really mean not factorable using integers. Okay, this was the whole strategy for binomials. So every time you're given a binomial to factor, this is it, nothing else. Now let's talk about factoring trinomials. These are way more involved and the most difficult ones, trinomials. Okay. What is the strategy? 1, descending order. Always. 2, greatest common factor plus negative leading coefficient. They can be in the same step. 3, what is it? And the answer in this case is a trinomial. 4, of course, special products. There is only one the one that we looked at, we studied last week, which is a squared plus 2ab plus b squared, and of course, or minus 2ab. Last week we discussed this direction. This week we discussed this direction. Does anyone remember what this was? The right-hand side. What did we have here that expanded into a squared, first term squared plus 2 times the first times the second plus the second term squared? What did we study last time that expanded into this? Anyone, please? We studied these two special products last time. Go back to your notes and say, oh, I remember. It was this. Please, anyone remembers what we studied last week? Not just last.
Parentheses with the term in it raised to a power?
Yes.
I don't know what it's called then.
Good, but what do I have here? To get a squared plus 2ab plus b squared, what should I have?
A plus b?
Exactly. Absolutely. It's a binomial squared. And of course, if this is negative, then this is negative. Very good. Good. Okay. 5. X squared plus bx plus c. 6. A x squared plus bx plus c. Let me explain the last two. Polynomials, trinomials, binomials don't have to be factorable. It's nice if they are factorable, but they don't have to. So I have to go through the steps. Descending order, greatest common factor, and or the negative leading coefficient. What is it? It's a trinomial. There are only two special products. It's actually one. Just the difference is the sign. But if a special product does not work, we have two more options for trinomials, which we did not have for binomials. As you see, the strategy stops here. There is nothing else. Descending order, negative leading coefficient, greatest common factor. What is it? Special products. Done. Nothing else follows. But for trinomials, we have two other chances. So what I'm saying here is, if a special product, if there are no greatest common factors, no negative leading coefficient, and no special products, then the binomial, as we just had, is prime. There is nothing else. I don't have other options. But for trinomials, we do. If these two don't work, the special products don't work, the number 5 doesn't work, number 6 doesn't work, then we say it's prime. But here, we only had special products. And then we said, that's it. I don't have anything else. It's prime. But for trinomials, we have more work to do. That's why I was saying there are more involved. So, what is this? This is a special case of this case, in which the leading coefficient is exactly 1. This is easier than this, of course. So, I'm given a trinomial. We're going to look at examples right now. I'm given a trinomial. What do I do? Descending order, greatest common factor, negative leading coefficient. What is it? I identify it as a trinomial. Does the special product work? No. Is the leading coefficient 1? Yes or no? If it's not 1, then I have the last chance, number 6. Okay? So let's see how this works. Let's look at examples. Here they are. Let's start with y squared plus 121 minus 22y. Y squared plus 121 minus 22y. Okay. Do not skip any of the steps, please, ever, 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 ever. Descending order? No. Y squared minus 22y plus 121. Greatest common factor, now in 3 terms? No. These 3 terms do not have a common factor. Negative leading coefficient? No. Special product? I always hope for a special product. I need another prop here. So when I look at this, I identify it with there is something I square. There is something I square because it's 11. 11 squared is 121. And there is minus. So what do you expect to get? Y squared is y squared. 11 squared is 121. What do you expect to get? I intentionally covered the middle term. I don't want to look at the middle term yet. I'll make a point in a second. So what do you expect to get? Obviously, you expect to get the one with minus. But what are the terms inside? It's okay if you're wrong. What do you think the term should be?
Y and 11?
Exactly. But now do you remember when we expand this, how do I determine the middle term? It's the negative. It's 2 times the first times the second. That's the middle term here. Because remember, when we square this, we get the first term squared minus 2 times the first times the second plus the second term squared. So the middle term here is 2 times y times 11, which ends up being negative 22y. If the middle term here is not negative 22y, this factored form does not equal the beginning trinomial. But it turns out that it is exactly what it should have been. So then the factored form of this is indeed this. First term squared minus 2 times the first times the second plus the second term squared. Now, you may have difficulties with this if you did not put the effort in last week to understand the pattern. If this is foreign language to you now, you have to go back and redo the notes from last week. So, as long as the first term and the last term are perfect squares, I can say, oh, this must be y minus 11, everything squared. But you cannot leave it alone and move on to the next problem. You have to make sure that you check the middle term. Because see, in this calculation from this step till this step, I didn't even look at the middle term. I assumed whatever, but it may or may not be the case. So here's a counterexample. So if I have a similar situation, if I have x squared plus 10x plus 36, you can say, oh, there is no problem. This is very clear. It must be x plus 6 to the second power. But then when I ask you what is the middle term in this expansion, what would you say? Can anyone give us just the middle term? Not the x squared, not the 36, just the middle term of this expansion. What is it? 2 times the first times the second. What is it? Two times the first times the second. What do we get? 2 from the formula times the first times the second. What is that? Can anyone multiply 2x and 6 for us, please? Anybody? Alan, can you multiply 2x and 6 for us? Okay. Arian, can you multiply 2x and 6 for us?
Repeat that, please.
2 times x times 6. I just wanted somebody to multiply 2x and 6.
One moment, yeah. Would it be 2x and 12?
Say it again.
2x and 12.
2x and 12. This is not a distributive law. We only have 3 factors. We have to multiply those factors. We are not distributing. The distributive law requires addition and multiplication or subtraction and multiplication. So we're not distributing. We're just multiplying. So then 2 times x times 6 is?
12x.
12x. Very good. But is this 12x?
No.
No. So this is not the factored form. The point I'm making with this example is, yes, when we decide the special product for trinomials, yes, we look at the first term and the last term. But then we have to check the middle term of what we come up with. I came up with, according to x squared and 36, I came up with x and 6. And I said, oh, that's it. No, it isn't. Because the middle term here has 12x. This is 12x, as you said. But the middle term here is 10x. So these cannot be the same. This does not factor into x plus 6 to the second power. But here, this is the same. Because I checked the middle term. And it's the same as it was in the original trinomial. But here, the middle term is 12x. It's not the original middle term in the trinomial that was given to us to factor. So then x plus 6 squared cannot be the factored form of x squared plus 10x plus 36. Is that idea clear? That's very important to understand. So when I identify the special product, I don't look at the middle term. I blindly put this in. But now I have the responsibility to check the middle term. And if it's not in the original, I'll say, no, no, no. Oh, that's incorrect. Okay, moving on to another example. Stop me if you have questions, please.